Good morning, everyone. I hope you are able to hear me and see my screen. Am I audible?
Yes,
sir.
yes, Karthik.
Yes. Yeah, thanks. So, do we have anyone who joined newly for today? I repeat, do we have anyone who are not part of past two classes and joined today only for the first time? Okay. I take that response as no. So we'll quickly rewind about what we have discussed in the last two classes, and then we can get started with the lambda expression for today. So whoever has joined newly, since the demo classes, so I am repeating the past two classes. So when the original class starts, then we are going to discuss about the rewind of the 10 minutes of topic. So for this course, the prerequisite is the having the core Java knowledge. And in this course, we are going to learn about the Java 8, 9, and 11 features. And if you would like to know the detailed topic wise, please look at the previous videos. And the course duration is around within 1 month we are going to cover, and the class everyday morning class timing is 9 a.m. to 10:30 a.m. and the fee for this course is 4,000 rupees, and for this 4,000 rupees we are going to provide you the recordings as well, and the recordings access will be there up to 3 months. We are not going to charge anything extra for the recordings, and I'm going to share the notes as well. So this is about the course details. Anyone joined newly, and do you guys need any more information on the course details? Okay, fine. So if anybody would like to know any details about the course, you can put your question in the chat. I'll take that question in the end. Now, yesterday we started with knowing or learning the Java 8 features. We have started with interface changes in the Java 8. Can someone tell me what are the changes that are done in the Java 8 interface? What kind of a methods can we write?
Default and static methods.
Can we write the private methods?
No, we cannot write. In
No.
Java 9, we will introduce it.
So what is the advantage of having the default methods?
Backward compatibility.
Backward compatibility.
Yeah. And you guys know what is the backward compatibility, right?
Yes.
Yes.
Yeah. So because whenever you say that it's a backward compatibility, they might ask you what does it mean. So you have to create a class, try to implement the interface, and tell them that if it is abstract method, you need to write the code in all the three classes, because whenever you introduce abstract method in the interface, you need to override in all the classes wherever it is getting implemented. So now in these three classes, you need to implement it. But when you write a default method, you don't need to modify the code. Can I override the default method in the interface, whatever the method that is present in the interface in the class?
Default method we can.
How to access the default method?
We can create the
Interface name dot super dot.
interface name super dot method name.
Yeah, interface name dot super dot default method. So can I override the static method present in the interface?
No.
No.
Is redefining the method.
It
We
doesn't
can
matter whether,
directly call it in main.
yeah. So in static overriding is not possible for a static method. It doesn't matter whether it's an interface or class. Okay. Now, in order to access the static method, we use the interface names followed by the static method name. Now, so what is the advantage of having the static methods in the interface?
Provides the utility method.
You don't need to provide, you don't need to create a separate class just for small utility methods. Example, you can give that collections is a class, collection is an interface. Since that feasibility was not there, so earlier they, in order to provide that, they created a class. For going forward, you don't need to create a class. So this is what we learned in the yesterday class, right? Does anyone has any questions? I take that as a no. If you have any questions, you can put your questions in the chat. Okay. So every day, the fashion that we are going to discuss is we are going to rewind the topic of what we have discussed in the previous day for at least 10 minutes. Like the way I'm going to ask is like I'll be asking the questions. If you are able to answer it, that's well and good. If not, I am going to repeat it. Like when I say repeat, not entire class, I'm going to summarize that what we have discussed in the previous class for 5 to 10 minutes. Post that we are going to learn the new topic every day. Okay, and going forward, once I have explained some things, I'm going to give you the homework as well. Like when I say homework, it is not like a school. I'm going to give you some work. Whenever you have time, you can practice it. It's not mandatory that you have to do it. But what I believe is like whenever you learn any programming language, you will get the programming language only when you practice it. Correct. So that's the only reason we are going to give you the work for the day. Now, without any delay, let's get started with the lambda expression. Now, this lambda expression is something new for Java, but this lambda expression is already present in the Python programming language. So in Java 8, this lambda expression is introduced. So look at here, the statements. Lambda enables the functional programming. So we do not know, first of all, what is a functional programming. We are going to understand what is a functional programming, and lambda supports for parallel processing. So these are the advantages of lambda. So we are using for that lambda. Now, leave about the advantages. We are going to learn the advantages little later. First of all, learn what is a lambda and how to write a lambda. Okay. Now, so whenever I am using, so here I have a test interface. The way how to use this test interface abstract method, here display is a method. So I have to create a class. I created a class called example1, which is implementing a test and then writing the display method. Now, in order to call this display method, what should I do? Create an object for this example1 and then call the method. This is how we follow, correct? Now, let us look at that, how to write a lambda for this interface. Now, before that, let me give you some statement. Remember that statement. Lambda corresponds to, don't worry about the spelling mistakes and all. Lambda corresponds to an interface, and specifically abstract method present in interface. Okay, just remember this statement so that we how to write a lambda will become easy. Lambda corresponds to an interface, specifically abstract method present in an interface. Now, can I say that test is an interface? Is it an interface?
Yes, sir.
Yes.
Yeah. So we are going to write a lambda for this one. Now, how to write a lambda? Now, advantages of lambda we are going to see later, but we are going to see how to write a lambda. Now, if I want to declare a string variable, can I say that string is equal to, this is how I can declare the string variable? And if I want to declare the integer variable, is this the way? Can I say that these are the variable declarations?
Yes.
Yeah. Now, in this variable declaration, what does it mean by Karthik? Can I say that Karthik is a value? This value is held by the variable called S, and this S is a type of string, correct?
Yes.
Similarly, I is a placeholder here. What is that means the variable is nothing but a placeholder. This I is holding the value of 10, and it is type of integer. So similarly, Karthik is a value which is held by the variable called S, and it's a type of string. Okay, you are putting a data type, variable name, and then what is the value. Now, similarly, what according to the above statement, what can I say? Lambda corresponds to an interface. That means you are writing a lambda for an interface, correct? See, whenever you are writing a string variable, you are using a string data type. Whenever you are writing a int variable, you can use a capital integer or small int. But similarly, whenever I want to write a lambda, So lambda, can I write a lambda for a class? No. Can I write a lambda for a method? No. Lambda, you can write a lambda for a interface. Now what interface I'm trying to write? I want to write a lambda for this test interface. So now I have to put like this, test t equal to, okay. Now, whenever you look at this statement, lambda corresponds to an interface, specifically abstract method present in the interface. That means in this interface, whenever you are implementing this interface, what you are doing, which method you are overriding?
Abstract method.
What is that here in this example? Display method. That means you are overriding this one, right? Copy this. That means whatever the abstract method present in the interface, whenever you are implementing in a class, can I say that you are writing the implementation for that?
Yes, sir.
Okay.
Yes.
Now let's remove, for time being, let's remove this. Okay. So this is the implementation that you have done. Okay. Now this is how see, this is a abstract method. Display is a abstract method present in the interface. For this display, you are writing a lambda. I mean, for this interface you are writing, but when you say interface, indirectly you are writing a lambda for abstract method present in the interface. So here, do you know, whenever in the interface, do you know what is the logic? Does the display method is performing?
No.
No. Whenever you are implementing in the class, can I say that you are overriding that method and providing the logic?
Yeah.
Yes, sir.
Yeah. So now here, did I implement that interface here in this class? I removed it, correct?
No. Yeah.
Because I don't want to implement. I want to write a lambda. Okay. With a lambda, you don't need to implement it. Okay. Now, so how did I write? Similar to a variable string s equal to Karthik. That means Karthik is a value and s is a variable which is holding the Karthik value, and it's a type of string. Similarly, I want to write a lambda for test interface. You can write a lambda for an interface only. You cannot write for class. You cannot write for method. So lambda corresponds to interface. That's the reason which interface I am writing test. And what is the variable name I kept? T. It's a reference variable similar to this variable. Okay. Now specifically it is an abstract method. What is abstract method present in this interface? Display method. So you want to override. See, public void display. This is a implementation I am writing. Correct. So this is you can call this as a lambda, but still we are getting some compilation errors. Let's resolve this one. Now here when I write this one, automatically compile. See, by writing like this, can I say that automatically compiler will understand this developer, whoever is writing the lambda, he is writing a lambda for a test interface, and in the test interface, currently we have only one abstract method. Can I say that automatically compilers knows that this person is writing a implementation or lambda expression for this display method only? We'll come to the scenario of having the multiple abstract method later, but at this point of time, we have only one abstract method. So by default, whenever you are writing like this test t, what the compiler will know that this developer is writing a lambda expression for the default method, for the abstract method present in the interface. So what is the abstract method? Display. Automatically the compiler will know that. So you don't need to provide the method name, remove it. And you don't need to provide the access modifier and return type. Why you don't need to provide? Because whenever you write a lambda like this, what compiler will do? It will go to your interface and it will look at your abstract method. By looking at this abstract method, it will it will do the compilation. So you don't need to provide a method name. You don't need to provide the return type. Okay. Now, does this method is taking any arguments? No. Okay. It is not taking any arguments. No, it is not taking any arguments. Okay. Only the extra thing that you have to do between this is the arguments and this is the implementation. Correct. This is what I want to write a expression, or I want to provide the lambda implementation. So between the arguments and the implementation, you need to provide one arrow mark. This is nothing but a lambda expression. And at the end, put the semicolon. That's it. So this is a lambda expression. Okay. Don't worry about that. I'll repeat again. One more small change we can do. Whenever you're writing a if condition, Can I say that this is how you will write a if condition? If and else, correct? Yes or no?
Yes.
Okay. Now, whenever you are having only one line of statement in the if, do you need this curly brace? If you have only one line of statement?
No.
No, right? So if it is a one line, you don't need, right? If it's a one liner of statement, then you will not put the curly brace. Similarly, here, which method I am overriding? Display method. You haven't provided the method name, but how the compiler will understand? See, you are providing test T. By looking at this test, it will go to the test interface, and the compiler will understand that person is providing the implementation for this abstract method. What is that abstract method? Display. Does it take any argument? No. That's the reason here also no argument. And what is this curly brace? Curly brace is telling you the implementation. What is this implementation? Display method is providing one system.out.println. How many statements I am executing here?
Single statement.
Single statement. Now, similarly, in the if block, if it is a single statement, I don't need the curly brace, right? Here also, I don't need the curly brace. Remove the curly brace. Done. So this is nothing but your lambda expression. Done. So you have written a lambda for this one. Okay. Now, once you implement the, see here, have you implemented the interface in this one?
No.
No. Okay. For example, assume that you do not know lambda till 1.7. How do? You will implement the interface first and then override the abstract method. How do you call this abstract method? By creating an object for this, right?
Yeah.
By creating an object and then calling. So now here, that means you need to call the method. So now can I say that by using test T, you have provided the lambda. That lambda contains what does the display method will do, correct? Now you need to call the display method. How to call? Instead of, see, this itself is nothing but an object, T.display. So now let's run the program and see what happens. See, in example one, display method. See, in this one, did I implement the interface?
No.
No. But am I able to write the lambda? Yes. Whenever you are writing a lambda, you don't need to directly implement interface and you don't need to create an object of that class. Automatically, if you are using this lambda reference, you can call that method. Automatically, internally, the Java will create JVM will create an object. Okay. So this is how you need to write a lambda. For example, if I want to perform multiple statements, then this curly brace is needed. And at the end, semicolon, because here, let me create one int x equal to 10. Now here, how many statements I am performing? 2 statements. If you are performing more than one statement, you need to write a curly brace. Now let us write the lambda expression for some more interfaces. Okay. And then we'll come to the explanation of what happens when more than one abstract method is present. Let's write one more interface called test2. Sorry, I have created a class by mistakenly. So let's remove this. So whenever you're writing a lambda, do you care about the method name? Abstract method name?
No, sir.
No.
No.
Correct. Because compiler is least bothered about the method name, return type, etc. Correct. Now, let me create a method which takes the int return type and method name is display. Let me take the method name as show and it is taking one argument in text. Okay. Now I want to write a lambda for this one. Now let me create a separate class and then write it. Whoever is not speaking, please go on mute now. So I have created a lambda expression separate class. Now, do I need to implement the test2 interface in order to write a lambda?
No.
No. What is that I told? First, whichever the interface you want to write, you need to write that. Let me remember string x equal to Karthik. What does it mean? Karthik is a variable, x is a Karthik is a value, x is a variable, and string is a type of the variable. Now, which interface you want to write a lambda? put that test2, and then T, you can put this variable name anything. Because here, can I say that variable can be anything
Yes, sir.
like this? Yeah. Similarly, whenever you're writing a lambda, this is also you consider it as a variable only. Okay, you can put any name now equal to. Now, after this, in the test2 interface, whenever I'm writing a lambda for test2 interface, what does it mean? Can I say that I am writing the logic for this method, abstract method?
Yes.
Now copy that method directly as is, and then put the, so whenever you're writing a logic in whether it's a class or anywhere, can I say that you will use the curly brace?
Yes.
If it is
Okay.
one statement, we know it's
No,
more
but
than
let
one
us let us keep it as a curly brace so that later we can remove it, because you may see the compilation error. Okay. Now, so do I need to put the method name whenever I'm writing
No.
a lambda?
Not required.
Because the compiler will it's intelligent. Java 8 compiler is intelligent enough to know that developer is writing a lambda for which method. Okay. Now this is not needed. And whether do I need the int return type? No.
No.
How does the compiler will know? By looking at the abstract method signature, it will identify what is the return type, etc. Now, what is it taking? Int x. Okay. Now, what is the statement I want to perform? I want to perform system.out.println x. Okay. Now here, only one extra change that you need to do. So whenever you're writing this lambda expression, see, these brackets will tell you that arguments, correct?
Yeah.
What type
Yes.
of argument the method is accepting. And can I say that this curly brace will tell you the implementation, what you're writing, correct?
Yes.
So between these brackets and implementation, you need to put this arrow mark. Now this is a lambda expression. Okay. Now here already x is defined, so it is showing the compilation error. Let me put T. Okay. So if you want, you can put this data type. Now, whenever the compiler is looking at this abstract method, does it know what type of a data it will be you are passing? Yes, right? By looking at the
Yes.
signature, it can identify. So you don't need to put this data type also. Correct? Yes or no?
Yes.
Yes.
Okay. Now here, whenever you are writing multiple statements, see why am I getting a compilation error here? Add return statement.
Return
See.
type is there.
Yeah. I did not write a return statement, but compiler is giving me the return. Earlier, I did not give. So let's modify this to void. Let's modify this to void.
What?
Am I getting a, let's see whether I
No.
am getting a compilation error? No.
No.
That means, can I say that whenever I writing a lambda, automatically compiler is going to this test2 interface and looking at this abstract method
Yes.
and then defining, right? See, whatever the statement I told, in order to write a lambda expression corresponds to interface, specifically abstract method. Now, can I have did I proven that by looking at the abstract method? Like compiler is looking at the abstract method. Now let's modify it to int. So whenever you're modifying it to int and saving, why am I getting a compilation error?
There is no return type.
Yeah. Can I say that now because of this, you are writing a lambda expression for test2 interface. Then compiler is going to this test2 interface and looking at this method signature and then saying that this method is returning int. So you are returning, you have to write a return statement. Agree?
Yes.
So that means, can I say that lambda is nothing but it is, so can I say that this statement is proven?
Yes.
Okay. Now let's write the return statement. Return T. Okay, done. Now here, whenever I am writing multiple lines, I need the curly brace. Now I don't want to use a curly brace. Okay. Now can I directly remove this one and then write directly? I don't want to print it. I just wanted to return T. Correct? See, I don't need even return because automatically the compiler will understand that you are returning only one statement. Correct? You don't need to even write a return statement. Hope you understand.
Yes.
Now, so can I say that now I have written a lambda expression? That means when I say I have written a lambda expression for test2 interface, can I say that I have written the implementation for the show method? What is that implementation here? Whatever the argument that you pass, you are returning that argument, correct? Now
Yes.
I want to execute this method. How do you do generally?
Just
Call
call
it.
Yeah.
Difference.
So that
Or
so
dot.
generally, whenever you are creating a class, implement the interface and then create an object of the class and call it. Similarly, here you have already written a lambda expression. What is the lambda expression name? R. So put that R. You just enter R dot. Automatically, are you able to see the lambda expression here?
No.
R dot show. Just pass the variable, whatever you want. Let me do sys out. Whether it is printing or not, let's see. Let's run the program. See, am I getting the output? Now let's run the 2 lines of execution. So whenever I'm writing 2 lines, why, see, can someone tell me whenever I'm writing more than 1 line, why the return statement is needed?
So which statement that will have to return? They don't know. I mean.
Yeah, the compiler does not differentiate. See, for example, here I am writing 3 lines. Int x equal to int c equal to ab. Sorry, 10. Now out of these 3 statements, or let me create int double z equal to 10.0. Now I have multiple lines. Now, if I am not providing the return statement, how does the compiler know that this programmer is returning a C value or Z value? How does it know? It does not know, correct? Whenever there is one statement, you don't, there is no option, right? Only whatever it is there, it will be considered. But whenever you have multiple things, you have to tell what you are returning, correct? So I'm returning T.
Yes.
That's the reason you need to write a return statement. Now let me execute this code. See, it is system.out.println, it is printing here, and then it is printing here as well. So this is how we can write a lambda. Shall we write one more lambda? Yeah, so not a problem. See, here you can put one more argument as well. See here, first lambda, what it is doing? Does it take any argument?
No.
Does it return anything?
Nothing.
No.
Okay. Now what is the second type? Does it take anything?
It's taking one. Returning
It's
one.
taking one argument and returning one argument. Let's write different way. Text 3. Whoever is not speaking, please go on mute. Now, can I say that this is nothing but taking one argument and not returning anything?
Yes.
Yeah. Can we write the lambda for this? Test 3 T3 equal to what is can I write directly? See, I'm not copying like that now. So what you need to do? How many arguments is it taking? One argument. So can I say that you have to put the first brackets and then this one arrow mark and then this symbol. Can I say here you are passing the argument? So here, do I need to mention whether I am passing a string argument or double argument?
No.
I just need to provide some variable name, correct? Whatever I want. So what does this F? F is nothing but a string variable, correct? Because by looking at this method, it will understand. Okay. Now, what is the implementation I want to write? I just wanted to print it. F. So this is nothing but a lambda expression now. T3 dot, see, look at show method. And let me print Karthik. Right? Let's run the program and see. See, Karthik is printing. Correct? We have written another lambda. Let's write one more lambda. Text 4. Okay. Now here, public string show. So now does this method taking any argument?
No.
But it is returning some object, correct? Now let's write the lambda for this one. How to write a lambda? Interface name test4 t4 equal to curly brackets and then implementation. Now here, do I need to pass anything?
No.
Not required.
Not
Because my abstract method is also not taking anything. But it is returning something. What I will do return
Nothing string.
If it is a single statement, I don't need to even write the curly brace, but let's write it, not a problem. Okay. Now, what is that method? Show. So do I need to bother about the return type of the method name? It can be anything, correct? Now let's run the program. See, Java features class, right? So are we able to write so now, see, generally whenever you are writing a lambda or whenever you have a method, what are the possibilities would be there? You have a method which takes an argument. There are 4 possibilities, right? Method. I'm just putting a method. You'll get to know why am I discussing this one little later. Method taking an argument and returning anything. Like when I say that int means here the return type can be anything, string or something. Okay. Method which does not take the argument but returns something. Okay. Method which takes an argument but returns void. Okay. Method which does not take anything, which does not return anything. Correct. So can I say that these are the different variations of a method?
Yes.
Yes or no?
Yes.
Okay. Now you will get to know why am I telling this one. Just remember this for time being. So can I say that we have written the lambdas for all of these kind of variations? Test 1, 2, 3, 4.
Yeah.
And does anyone has any questions so far?
Sir, one of these, we are writing the test interface reference variable outside the main method, and we have to call that reference variable. We have to call inside the main method. It is working on.
So wherever you're writing a lambda, whatever the lambda reference variable is there, with that reference variable you need to call. So
inside
why
the
am I
main
writing
method.
the main method? See, it doesn't matter in the main method. You can write in anywhere. You can write a lambda in separate method also. Let's write public void add. There is a method. Now your question is, you are thinking that I can write the lambda only in the main method, right? It's not like that. Let's write one more lambda. Test4 t r equal to, what is the test4? Does it take any argument?
Yes,
No.
It does not take, and but it returns, right? You can call, but when this method gets executed, whenever you call this add method only, right? From main method, you need to call the add method, right? Why did I write in the main method? Because main is the method that gets executed first, correct?
Yes.
Now, if you want to get, see, now is your doubt clear? We can
Yes,
write
sir.
the what you call
At anywhere, but we need
anywhere.
to call that particular.
Yeah. So here you have written a lambda expression in the add method. So
That-
can I say that whenever the add method is called, then only this lambda expression will be executed?
Yes.
That means you need to create an object and call this add method. Then only this lambda will be. So there is no condition that lambda you need to write in a main method, because whenever you are using our applications in the project, does that applications will have the main method?
Spring Boot,
Oh,
you have to take.
Sometimes.
No, we are writing the web-based applications, right? Which does not have a main method, right? So if there is a limitation of a lambda that you can write in the main method, this is useless topic, correct?
Yes.
Because whenever you are working in the web-based application, you are writing a REST web services, correct? From directly from the HTTP, you are calling the REST service. Is there a main method involved?
No.
You're starting in order in the Spring Boot. Spring Boot, we have a main method. Why that is needed? In order to call your server. In order to create the server and then deploy the application, you need it. But whenever the request is coming, do you have any main method?
No.
No, right? It is just a endpoint. From that endpoint, you are writing your logic. So in order to write a Lambda there is no condition that inside a main method, outside a main method, wherever you want, you can write a Lambda. But it is just a common sense that whenever you are writing a Lambda in the add method, you need to call the add method so that this Lambda gets executed, correct?
Yes.
Yeah. Any other questions, anyone? I hope this
Yeah.
lecture made how to write the Lambda easy.
What is the advantage, sir?
1% at a time, please.
Yeah.
Yeah.
If I want to write a lambda expression, shall I require compulsory interface or any other things also possible?
Only for interface you can write.
Yeah. Okay.
It is functional interface.
Can you
I'll
please
come to
go
that
on?
functional interface little later. I'll come to the function. Why the functional interface? See, you are saying that functional interface, but it is also a interface, right? Why we need a functional interface? What is the problem that we face? That we are going to discuss about little later after the doubts have been clarified.
Can you please once show that your screen?
Down?
No, not down. That another screen you were showing, right? String method, that 4 type of methods you do.
Yeah. Then see, name of a method, taking an argument, returning something. Don't take an argument, return something. Take argument, return void. Don't take argument, don't return anything. Correct?
Possible.
Sir, only advantage is we don't need to implement interface in our class. That is the only advantage which is Lambda.
So the functional programming is also there. Lambda enables the functional programming that you are not aware of is as of now. I am going to explain that later. What does mean by functional programming, etc. So we haven't discussed about the advantages of Lambda. We just have discussed about how to write a Lambda. We are going to discuss the advantages of Lambda little later.
One question, Karthik, like if we have an interface with multiple abstract method, in that case, how?
Yeah,
we
I'll come
can-
to that. I'll come to that. That's where the functional interface topic has come into the picture. Okay. There is a concept of functional interface in Java 8. That's where the functional interface topic has come into the picture. Just let me know if you have any questions on how to write a Lambda so far with one abstract method. If no, then we'll continue. Does anyone any questions? Yeah, fine. So now let's continue. Now it's well and good, like whatever the thing that you have written here, it's working. Now next question, the one who asked, what happens whenever we have multiple abstract methods in a Lambda? Can we write first of all? Okay. Now let's introduce one more abstract method here. Public int add. Okay. Now I'm writing another abstract method. Okay. Now I'm saving it. So in an interface, can you write multiple abstract methods?
Yes, sir.
Yes.
Yes. So that's the reason. Are you seeing any compilation error here?
No.
No, it is possible. That's correct. But whenever you go to this Lambda expression example, this class, are you seeing compilation error here?
Yes.
Yeah.
Line number 30. What does it is telling? The target type of this expression must be a functional interface.
Yes.
So now let's understand what is a functional interface. First of all, understand why am I getting a compilation error. Now, I'll just wait. Let me complete my explanation. Then you can. Now, if you remember the statement that I told, Lambda corresponds to an interface and specifically abstract method present in an interface. Now, in my interface, how many abstract methods are there? 2. Okay. Now, the method signature might be same or different. It doesn't matter. But I have 2 abstract methods. Now, whenever you're writing a Lambda, how does the compiler know that which abstract method you are writing the implementation? Correct. The compiler is not able to differentiate. Our compiler is having a redundancy. So it is not able to differentiate which abstract method you are trying to provide the Lambda expression. So that's the reason any interface which has a multiple abstract method, or any interface which has more than one abstract method. For that interface, you cannot write a lambda. Now, there is a limitation whenever you write a lambda. Whenever you write a lambda, that interface should have only one abstract method. Okay. If an interface is having multiple abstract methods, we cannot write a lambda. Even if you write a lambda, compilation error will be shown. Why the compilation error will be shown? Because the compiler is not able to differentiate or know which method that the user is trying to write the implementation or lambda. So that's the reason writing whenever the interface is having a multiple abstract method, writing the lambda expression is not possible. Now that's good. Okay, fine. Let me write only one abstract method. Okay. Now this is the interface test4 has written by the Karthik, correct? Now the error is gone. Now I have written this interface. This is the code I have written. Assume that in my project, I have another people called, like we have other developers called Bharat. Assume that Bharat is present in this class. He's also my project mate. Now he wanted to, now here I am writing a lambda. So if Bharat is coming and adding one more abstract method in this test interface, my lambda expression is getting failed, correct? Am I right? See, in my project, there are two developers. Karthik is the developer who has written this interface and who has written this lambda. Now, Bharat is coming and then adding one more abstract method in the interface. Can the Bharat add one more abstract method in the interface?
Yes, sir.
Yes, he can add it. But when he adds it, my lambda expression project is giving a compilation error. Now, can I say that since I have written this one, I should not allow Bharat to write one more abstract method, correct?
Yes, sir.
That means what I have to do, I should not, whenever I am writing a lambda for an interface, I should not allow anyone to write more than one abstract method, correct? Yes or no?
Yes.
So if Bharat is a developer, if he is trying to write the abstract method here, I should not allow him. So in order to restrict the interface having a more than one abstract method, whichever the interface that you are writing, you need to annotate it with functional interface annotation. See, there is an annotation that is introduced in the Java 8 called as @ functional interface. If you annotate your interface with this annotation, then what happens? It will not allow that. Now let's write. So after doing this one, Bharat is coming and adding one more abstract method. Now look at here.
Showing compilation.
Now here, earlier I did not get a compilation error. But can I say that now, whenever the Bharat is adding the one more abstract method in my interface, here itself I am getting a compilation error, correct? Invalid function interface annotation test4 is not a function interface. That means, can I say that Bharat cannot add one more abstract method?
Yes.
Now, can I say that no one will disturb my my lambda expression now? If I annotate the interface with the @ function interface?
Yes.
Yeah. So that's the reason whenever you are writing a lambda corresponds to an interface. You should not allow anyone to write more than one abstract method. So in order to do that, what you need to do? You need to annotate the interface with @ functional interface annotation. So now this is called as a functional interface. So what is a functional interface? A functional interface is an interface in which you have only one abstract method. You can write any number of default and static methods. Let me write. See, I am writing one default method. Let me write one more default method and see whether does it give any error. Let me write static method. See, how many default methods are present in this interface now?
2 default, 2 static.
Multiple.
So am I getting any compilation error?
No.
Neither in the lambda expression nor in the interface, correct?
Yes.
Now the question comes in the interview, what is functional interface? what is functional interface and why the functional interface is needed. Correct? So why the functional interface is needed? Whenever we are writing a lambda, lambda corresponds to a interface. So so whichever the interface that I am writing a lambda, that interface should hold only one abstract method. I should not allow any other person to write more than one abstract method. In order to limit the interface to have only one abstract method, the possible way is by providing the @functional interface annotation. By providing @functional interface annotation, can I say that that interface is called as a functional interface, and it can allow only one abstract method, and it can have any number of default and any number of static methods. Is it clear?
Yes, sir.
Yes or no?
Yes. Yes.
The one who asked the question on multiple abstract method, does it clear now?
Yes, clear.
So these are single abstract method interfaces are also called as SAM. SAM means single abstract method interface. That is also called as functional interface as well. Okay. Any question, guys? So when I ask the question, whatever the topic discussed so far, you can ask me the questions in that. If there are no questions, we can go further. Because the reason I'm asking is, if you have a question, you will not be able to concentrate on the further, right? Your brain will keep on scratching on the question itself, right? So that's the reason. Other tutors may not ask you like this. They will take the questions at the end. But I just wanted to make sure that whatever I explain, it is understandable by you, so that you can concentrate on the other topics.
Go ahead, sir.
Yeah, thank you. So now we understand how to write a lambda. We understand what is a functional interface. Now the question comes, sir, functional interface is something, only one abstract method should be present. Now, if in my project, if I want to write a functional interface, every time I have to create an interface, correct? That means number of interfaces that you are creating will become more. Yes or no?
Yes.
Yes.
So that means it will be a disadvantage only, right? Number of interfaces you have to create, it will be a disadvantage. Okay. Now, in order to overcome that disadvantage, so in Java 8, they have created a new package called java.util package. Okay. Now, before going that, do you guys know how to see the source code of a Java?
Yeah, we can use a decompiler, and in that inside JRE bin folder we have rt.jar, runtime jar, so that we can open and check what that packages are available.
So does the others are aware of that? What is a decompiler and etc.?
No.
Yes, sir.
Yes, sir.
Check into the jar also. What you-
So whenever you write a Java file, you will compile it. Whenever you compile, the class file will be generated. The decompiler is something in the class file. Whenever you open the class file, you cannot understand the code, correct? So let me look at here for this Java 8 project. Let's go here. Documents, 0 to Java 8, Java features. Where does the Eclipse will store the class files? Where does the Eclipse will store the class file for a general normal project? For this, see example.java is there. Can I say that this is compiled? Automatically Eclipse does the compilation, correct? Whenever I write the code. Yes or no?
One classes file folder will be there.
Class folder.
Where it is?
Lib.
No. So whenever you create, observe that whenever you create a project, what is the folder that you can see here? SRC folder. SRC is nothing but source. Now internal, whenever you create a project, by default, the Eclipse will create a folder called bin. Okay. In this bin, same project structure will be there. Look at here, com, Ashok IT, Java 8 features. Com, Ashok IT, Java 8 features. In this one, it will store the class file. Now look at here, class file. Now, whenever you open the class file, are you able to understand what I have written the code?
No, sir.
Okay. That means from the, by opening the class file, I do not know what is the code, correct? So that's where if you have a class file, and you want to know what is the code, that's where the decompilation is coming into picture. The process of converting the Java file into a class file is called as compilation. Now the process of converting the Java code or getting the Java code from the class file is called as decompiler. So in market, we have separate decompilers. In market, we have separate decompilers. So in order to download the decompiler, go to Google Java decompiler, enter Java decompiler, and then go to the first link. Now here, based on your operating system, you can download. If you are using Mac, you can click on this one. If it is the Windows, you can click on this one. Once you click on this one, the decompilers, like it is not a software, you just need to open the jar file. So whenever you open this one, see the folder, the zip file will be downloaded like this. Okay, just click on this arrow. So just click on this one, a zip file will be downloaded like this. You just extract it, and then the folder looks like this. And I hope you are able to see one coffee cup symbol here. Does everyone is able to see the coffee cup symbol? Yeah, double click on this coffee cup symbol. Now this is a decompiler. Now if you remember, whenever you are downloading the Java and installing it, it will be installed in the program files, correct? If you provide specific location, it will be installed over there. If not, by default, it goes into the program files. Go to the program files, Java and JDK. So in this one, there is a folder called JRE, and then there is a folder called lib. Under the library folder, there is a jar called rt.jar. The jar file will contain the class files. Open this file here. See rt.jar. Double click on this. Now look at here. This rt.jar is the jar in Java which contains the source code. You guys know that java.lang is a package. Look at here. Java.lang is a package. And look at here. You know that Boolean is a class, correct? Wrapper class.
Yes,
See?
sir.
Are you able to see the source code for the wrapper classes here now? Similarly, you know that string, correct? String is a class in Java, yes or no? Float.
Yes.
Exception is a class. Are you able to see all the source code?
Yes. Yes.
Yeah. Now, similarly, you know that array list, correct? Java.util.array list. See? Are you able to see the source code of array list?
Yes, sir.
By using the this is the advantage of a decompiler. Now, okay, let's go back. Now, the problem that we have is whenever you write a Lambda, you need an interface which takes only one abstract method, which is nothing but a function interface. But writing the number of interfaces will be a headache in the project, correct? So in order to overcome that one, Java has created in the Java 8, under the Java util, you can see one function package. So this has been java.util.function. This package has been introduced newly in Java 8. This will contain the different type of interfaces. First interface name is predicate. Look at the predicate. So whenever you write a Lambda, do you care about the method name first of all? Abstract method name.
No.
No, right? No. Look at here, this function predicate is an interface. It's a functional interface. What does it mean? How many abstract? What is the meaning of functional interface?
Containing one
Only
abstract
one
method.
abstract
Sam.
method. Sam.
Yeah, only one abstract method and any number of default and static methods. Now, what is abstract method?
Test.
Okay. What does it is doing?
Returning only value.
Checking some condition and it is returning true or false.
So that means
No, it is having only one parameter.
yeah, it is taking one argument and returning Boolean. Let's write one more here. Method take one argument, some argument, and return Boolean. Okay. Now this is another type. So here in your project, if you have a requirement like this, do you need to create an interface now?
No.
Can you make use of this predicate?
Yeah. Yes.
Okay. So that means this is taken care by predicate, correct?
Yes.
Okay. Now let's go back to the consumer. So see, consumer, is it also a function interface?
Yes.
So what is it doing? One abstract
Yes.
method, taking one argument and
an-
returning void. Can I say that taking argument, returning void? Is it also covered?
Yes.
Here the method is method name is method, but here the method name is accept. Do you care about that?
No, sir.
No, we don't. We are least bothered about the method name whenever you are writing a lambda, correct?
Yeah.
Okay. Now let's look at the supplier. What does the supplier? It's a function interface. What is it doing? No, don't take any argument, but return something. Don't take any argument, return something. Here, instead of string, I can return anything, correct?
Yes.
Let me put
Yes.
it as an object. Okay. Now, can I say that this is supplier?
Yeah.
Now, see, there's another interface called function. It's a function interface. Look at here. It is taking some argument and returning some other argument, correct?
Yeah.
Yeah. So can I say that this first is covered? Taking some argument and returning something else. This is called function. Now, these are the possibilities you can write, right, in your project. See, I don't worry about the multiple variables here. This is taking only one argument. Now the question comes, sir, what happens if it is more argument? I'll come to that later. But whenever you have a single argument, can you write more than these combinations, or these are the permutations and combinations?
These are the most combinations.
You don't even get more anything else, right?
Yes.
Correct?
Yeah.
Yeah. So now can I say that in your project, if you want to write these kind of things, can you use all the predefined interfaces, predicate, consumer, supplier, function?
Yes.
One question, that void method one is there, na, that we can consider as supplier only, right?
No, I'll come to this one. You have a runnable interface, right?
Yeah, yeah.
Which has a run method. That it does not take anything, it can take, it does not return anything. It is not supplier. Supplier is not taking anything, but it is returning an object, right?
Yes.
There is a difference between these two, right? Return type.
Yes.
Okay. Mostly we don't use this kind of a method, right, in the project. Ideally, we take something or return something,
Yes.
correct? This is not much used, but if you want similar for this one, the similar purpose is runnable interface, right? The runnable is having a run method which does not take an argument but returns void, right?
Yes.
Okay, well, let's keep this aside for time being.
Okay.
I can hear some different voice. Can someone go and mute? Okay. Now, so now here, the possible things are, these are the four things. That means function, supplier, consumer, predicate. These are the interfaces that are provided by Java. Now, before knowing this java.util.function and this function interfaces, we were facing a problem that if the number of interfaces or number of lambda expressions are more, you need to write number of interfaces. Now, can I say that with the introduction of this java.util.function interfaces, is that problem resolved? Do you need to create a separate interfaces, or can you make use of the existing interfaces in the Java?
We can make use of existing one.
So that problem is also resolved, right? Yeah. Now, let me quickly go back here and then check. Now, test 4 is doing what? It is not taking any argument, but returning string. Is it similar to this one? Not taking any argument, but returning something. It's a supplier.
Supplier.
Now let's see. Instead of test 4, let me remove this test 4. Okay. If I am removing, I'll get a compilation error, right? Okay. Now here I am writing. So if I want, if my functionality is like that, don't take any argument, but return something. Instead of test 4, can I say that I can use supplier?
Yes.
Supplier. It is taking an argument like generics is nothing but what time you are returning. Okay. String. Now this T4 dot, what is abstract method? Here, supply, just do control space, automatically it will show you.
Get.
Get upper.
Get is a abstract method. See, even if I do not now, let's go to the T3. Test 3. It is taking an argument, returning void. What can I use?
Accept. Yeah.
Now taking an argument, returning void. This one, consumer, right?
Yeah.
Now let's delete T3 also. If I delete, I'll go here. Instead of T3, what should I put? Consumer. Done. I'm letting here. Let me put string. Okay. This generics you need to mention. Now what is that T3 dot? Just put the abstract. Accept. That's. Now, is the compilation error gone? Yeah. Now let's go to the T2. What does the T2 has? Take one argument and return something. What is that? Function.
Function.
I'll remove the T2. See here. Function.
Taking some int and returning string.
It is taking integer here and returning integer. So R dot, what is the method name?
Apply.
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 Yeah, done. So let me remove this one for time being, this add method. Okay, done. See, earlier I have created multiple interfaces, but in my project, if this is the case, in my project, do I need to create any interface?
No.
Any function interface?
No.
No, right? I can make use of the predefined function.
Predefined.
Yeah, this is the beauty of Lambda expression. Now, hope you got what is the advantage. Number of lines of code is less, correct? But still there are more advantages of writing a Lambda expression. So Lambda expression basically provides functional programming. Functional programming is nothing but, till now, whenever you call a method, you will pass the arguments as a value. But Lambda enables, you can write functionality as a method argument. That we are going to see in the further class. Any questions?
Yes, sir, but where do we need this? We're not able to get that.
Where do
Yes.
we need in the sense?
This kind of like functional interface, like consumer. We have predefined interfaces and we're calling functions. No. In which scenario we'll use this?
In now, see here, in your project, have you created any interface?
Yes. But
Have you
not-
implemented it?
Yes.
Okay. Then that place, instead of implementing an interface and then overriding the abstract method, you simply write a function interface. You simply write a Lambda expression. That's it. Wherever you are implementing an interface and overriding abstract method, you can write a Lambda expression. That will make your number of lines of code is less.
Okay.
You don't need any specific real-time scenario. Wherever you are implementing an interface, there, see here, what does it mean function interface? Can I say that I have to see function is an interface, functional interface in which we have an abstract method called apply, correct? May I know your name?
Srivalli.
Yeah, Srivalli. So can I say that this function is a, okay, let us not take about function. Now, can I say that this consumer is a functional interface?
Yes.
What is that abstract method you have?
Accept.
Accept. For example, you forget about this Lambda expression. In your project also you have a interface called consumer and you have in that consumer interface, you have a accept method. If you want to use that, what do? You will come to the class. First of all, implement it, correct? Class implements consumer, correct? And then you
Yes.
will override the accept method, right?
Yes.
And then you will create an object for this class and then call the accept method. Yes or no?
Yes.
Now, with this Lambda expression, do I need to do that? Do I need to implement it?
No,
No.
by using Lambda expression we can.
Yeah. Can I say that it is making your life simple?
Yes, and it is only when we have one abstract method.
Yes, that functional. Yes.
Okay.
So that means in your projects also, if you want to create generally whatever the overhead that you are doing, creating an interface, implementing and all, So that is becoming easy, right?
Okay.
That means wherever you are implementing an interface which has a one abstract method and you are performing some operation and creating a object and calling the method, that in all those places you can reduce the work.
Okay.
But in real time, we are creating multiple abstracts, right?
Yes.
Then see, whenever you have a multiple, that is what, whenever you have a multiple interfaces, you will not create a lambda. In real time, there are some situations you just need to perform some operation. If you are getting a data, example, let me tell you, you wanted to display some data from the drop down, okay? Or you wanted to perform some calculation, okay? That calculation should return something. So generally, the way we implement in a project directly, we don't write a method. We'll write an interface and then implement. There will be a class which is implementing that interface. Okay. In this scenario, you are limiting the interface not to be written. You're just writing the lambda directly by using the predefined interfaces. Okay. So no one can replace multiple interface functionality because even there is no feature to implement that because no one knows what you can write. But if there is a single interface which you are trying to implement, then that can be replaced with a lambda expression.
Okay, sir. Thank you.
Yeah. Any other questions, anyone?
Yeah. Here we are already we are returning here integer. I think object. So shall I return into primitive data types here?
Yes. Yes, that also we can do. Okay. I'll come to that. Like we haven't completed this one, right? Entire topic. Yeah, we are going to look at that. There are some primitive types also there. Like
primitive data types.
Yeah.
One more question. So in project
here, int consumer. If you look at this int function, int consumer.
Okay.
See, it is taking int predicate, I think. Yeah, look at here. It is returning a small boolean. Int supplier. It is returning small int. Correct?
Yeah. Yes.
This is your question, right? If you want to return as a primitive, then you have to use the int supplier, not the normal supplier. Yes. Or else you can use a normal supplier. And see, whenever you use a normal supplier, can I say that T4 dot get whatever the return type you are getting, can I do dot small int?
Yeah, to int.
Int value, correct? You can call the int value method.
Yeah.
Yes, auto boxing and unboxing. Yes, go ahead.
Yeah.
What was your next question?
I have one. I have one question. Hello.
Yeah. Go ahead.
So actually, the question here is basically if you are going to write a small function, right? Which we are calling it as a lambda function, right? So why you need to have the interfaces, and then based on the interfaces you then
that's a good programming skill. So generally, if you write a method, anyone can write. In a class, if you write a method, anyone can create an object and call it. But by creating a tight coupling, the way generally the good programming follows is you create a interface and then interface will implementation class. So that you are restricting it. Like no one can directly create an object for that. See, you know that array list class, right?
Mm-hmm.
So array list is implementing a list interface. Okay. Now, why are you doing the list? See, whenever you create a list object, will you do like this? List L equal to new array list. Is this the way you follow, right?
Yes.
Okay. But why can't you do like this line? Which one you follow in your project? 36 or 37 line number?
37.
37. Are you sure you are following 37 in your projects?
36 only mostly we follow.
Mostly, we follow 36. Yes.
But writing the 37, is it wrong?
No, it is not wrong.
But why are we using 36?
I think that list utility classes we can use.
Okay, anything? Answer is dynamic polymorphism. That is right. What does it mean, that dynamic polymorphism?
List is an interface.
Yeah, it is an interface. What is the advantage you're going to get? May I know the person who asked the question? This one?
So
Very
use
good name.
use list methods and array list methods.
Yeah. So let me take one method called display, which is taking a list interface. Okay. Now, what are the classes which are implementing a list interface? What are all the classes that are implementing a list interface? Array list, vector, linked list, correct?
Yes.
Yes.
Okay. Okay. Now here, whenever I am using like this, whenever I am creating a parent reference for this vector, array list and linked list, what is the parent? List interface, correct? Whenever I am using the parent reference and then creating a child object, and you have a method like this, to this display method, you can pass array list object, you can pass vector object, you can pass linked list object. That means, can I say that your display method is, you can easily reuse it? But if you are using an array list object, then you cannot use it. You can pass only array list object. You cannot pass vector and linked list. So this is called dynamic polymorphism, right? So that's the reason in your project, you can see you are creating a reference with a parent and then creating a child object. Okay. So similarly in the project also, we create an interface and then create a IMPL class. Through the interface, we will create a auto wiring or creating an object. So in that advantage, you can create all the child classes. Whenever you create a method, you can pass the child class reference as well. Hope you get it.
Yeah.
Yeah, the one who had a previous question, can you please go ahead?
Shall we create a functional interface in real-time scenarios? And
Yes,
mostly
you can.
many location I see utilization of this one. I mean filters, maps, everything by using this supplier consumer. But in real-time scenarios, which location where I don't know. Actually, I'm not. Yeah.
You see, in real scenario, first of all, when you can create an interface anywhere, wherever in your project, you create some package and then create an interface, and by using that interface name, you can write a lambda, no problem. But when all the predefined, see, Java has provided the predefined interfaces, which is solving all your purpose, then why do you need to create, correct?
Yeah.
But still, if you want to create, you can create. How do you create? Just now I have created a test 4 interface, test 3 interface, right?
Yeah, okay. But in real time, I mean, if I interview or ask, what I have to say? That's the thing.
You cannot. That is you. If you want, you can create. No one is going to stop you. But why do you create?
Okay.
There is no scenario. In my 12 years, I haven't seen a scenario where you will come out of these 4 combinations. You will say that, sir, I have the multiple variables. Here, this is taking only one argument, but there is a possibility of multiple argument. That also, in order to fulfill that one, in the function interface, you have by consumer.
Okay.
If you look at here, if you look at by, see, the question will be, sir, what happens if I have 2 arguments? See, look at by consumer. How many arguments that by consumer is taking? 2 arguments. Now the question comes, what happened? What if I have 3 arguments? I cannot create a method like number of arguments, right? Then you can use a collection object, right?
Okay.
Yeah. In order to club the multiple objects, you can use a collection object, and that collection object you can pass it as a second argument, right? So all the scenarios that you face it in the real time have been covered under this. So you don't need to create it, but no one is going to stop you. You can, if you want, you can create it.
Okay.
So guys, like tomorrow and after tomorrow will be holiday. Okay. And the last demo class will be there on Monday, but don't delay it. Monday, we are going to discuss further topics. So the lecture would be the same way. I'm going to teach everything, like even stream. There are so many methods in the streams, right? And there are some extra methods have been added for a collection interface, and then optional class, and then time, date, local date and time API. Everything we are going to discuss in the practical approach itself. And I'm going to share the notes as well. If you are interested, I request you all to please do the enrollment by today EOD, because tomorrow and day after tomorrow, there will not be any class. Any questions? I hope this lecture makes you how to create a Lambda expression little easy.
Yes, sir.
Yes, sir.
No question. That's all for today, guys. If you are interested, please do the enrollment as soon as possible. And yesterday someone said that they haven't received the email. I hope you have received the email now.
Yes, I have received it.
Yeah. So go to the email, look at the instructions, and you can follow the instructions and you can enroll for this course. Okay. So thank you, guys. Thanks for
Thank you,
joining.
sir.
Have a nice day. Thank you all.
Thanks, Karthik.